Hi again, welcome back to part 2 of our chemical reactions work. This one is starting to look into a little bit more detail on how we actually describe the reactions, specifically writing chemical formula and equations. So just a quick recap on what a chemical reaction itself was. As we know, we've seen most of the materials that are used every day. These are formed by chemical reactions. And these happen when you combine or rearrange atoms to form new substances. So we describe those two parts as reactants, which are the substances that go into the reaction, and the products. So these are the things that come out at the end, that are produced. So we describe that process of the reactants turning into the products by a chemical equation. So during that chemical reaction, the reactants are pulled apart and rearranged to form the products. And so we describe that generally like this. The reactants turn into the products. So reactants, arrow, products. So the equation shows what is going in and what comes out. So here's an example, one that we've seen a couple of times now. Water is produced by burning hydrogen in oxygen. So we have hydrogen plus oxygen turns into water. So we use a plus sign to show that they're being added together, but then we use an arrow to show that that's turning into water. It's not equal to water. It's not the same as water. So this is what we call a word equation. So this type of equation is pretty useful because it's quick, it shows us what's happening overall, but doesn't give us all the detail that we might need to describe the actual chemical structure or what the atoms are doing, etc. So the word equation, a nice, quick, easy way to do it. But what we actually want to do is replace those words with the chemical formula. So chemical formulae are the names or the symbols, the descriptions we give to what the chemicals are and what's shown within them. So the chemical symbols are found on the periodic table. So each element has its own symbol, as you would find. Hydrogen is H, oxygen's O, nitrogen is N, lead's Pb, etc. If you're looking at a chemical formula and there's a little number after it, tells you how many of those elements there are, how many of those atoms there are. If there's no number, it means there's one. So we look at water, one that we've seen again a few times, H2O, formula I'm sure you're familiar with. What that tells us specifically is that there are two hydrogens and there is one oxygen. So we look at a more complex one, H2SO4. This is sulfuric acid. There are two hydrogens, one sulfur, and then four oxygens in this case. So if you had a large number at the front of the equation, the formula there, it actually tells you that there's multiple of everything. So something like this, 3H2O, that means there's 3 water molecules in total. So that's 3 times the 2 original hydrogens, so 6 hydrogens, and 3 times the 1 original oxygen, 3 oxygens. So that becomes really important when we look at balancing equations, making our equations add up later, but we'll come back to that in a sec. So when we're naming our chemical compounds, this is an important thing to be able to do, understanding that the names and the formulas for these equations actually relate to each other, and then knowing what to do with that and how to compare those two things. So the most basic of these substances that we're going to name, it will be one metal and one non-metal. And so for each of these, the way we name them is whatever the metal is, we name that first. And whatever the non-metal is, we change that name to ide. So here's an example. This is sodium and chlorine. Sodium is the metal. Chlorine is the non-metal. So Na sodium, Cl chlorine. And so we stick that together. We name the metal first, sodium, and then the non-metal, but we change the N to ide. So this stuff becomes sodium chloride. Here's another example. You can quickly pause and have a go at naming it yourself. that this is aluminium and sulfur. So the aluminium gets named first, and the sulfur, we change the end of it to "ide", and it becomes aluminium sulfide. So for each of these, we don't need to worry about how many atoms there are. We don't need to say anything about the numbers of atoms that there are when there's a metal and a non-metal. We just name the two types. So if there are pieces that are not just one non-metal, so it's a metal and something and then a group of things that are non-metals like this, KNO3. So potassium is a metal, but then nitrogen and oxygen are both non-metals. These get named a little bit differently. We still name the metal first, but then that piece at the back, so in this case the NO3, is given a special name. So it's in this case it's called nitrate. We don't call it nitrogen oxide or anything like that. They get their own name. So this stuff would be called potassium nitrate. So if it was just the nitrogen, K3N, this would be called potassium nitride. So potassium nitride is just the stuff, just nitrogen. This potassium nitrate has this NO3 in there. So these names, these complex names, have their own formula and are sort of included together as a group. So NO3 is nitrate, SO4 sulfate, carbonate, phosphate. There are some other ones as well. There's one more that you're going to come across a lot, and that's hydroxide. So with these names, it's not something that you'd be expected to remember off the top of your head, but you'd need to recognize the name or the formula and remember that there's something different. So if you saw an equation that was NO3 at the end, remember that that's not just nitride. Go check the little list that you'd have, because you do have access to this information in a test or an activity or anything like that. You would have this list of names. Go check what it is. SO4, what was that? Sulfate, off we go. So that's how we name things if they've got a metal. So metal first, and then whatever the back piece is, either ide or ate, probably. If there's no metal, we use a slightly different way. These are called covalent compounds, something that we'll come back to later. But we name these a bit differently. So where in our metal compounds, which are ionic compounds, the number of atoms didn't matter. If there's no metal, the number of atoms does. So we sort of name them pretty similar. Whatever's written first just gets the name, and the second one gets changed to ide, just like we did before. But this time we actually put a little bit at the beginning to tell us how many things there are. So CO2, the two atoms that are in there are carbon and oxygen. And we call this carbon dioxide. We have P2O5, diphosphorus pentaoxide. So these little prefixes at the beginning there, again, these are not things that you'd be expected to remember, but you'd be expected to recognize that that means that there is more than one, or remember that if you've got no metal in your equation or in your formula, that you would need to go and actually name these things using these numbers. All right. One thing to point out here as well, carbon in the first one, carbon dioxide, even though there's only one, we don't need to say mono to start with. So if the first atom only has one, then you can just say whatever it is. If it has more than one, like our diphosphorus there, then you name it. If the second atom is only one, so if it was just CO, not CO2, then we would call that carbon monoxide. Okay, so numbers on every second piece, but if it's on the first piece, then you don't need to name the number. If it's one, if it's more than one, then you put that number in. All right, let's put all that together. So we have so far seen the general format for an equation, reactants turn into the products. We've now seen the chemical formula. So now if we put those two things together, we can actually create a proper reaction, a proper equation using that information. So reactants turn into the products. So we'll stick to the same example we saw before, hydrogen and oxygen turning into water. So we replace those names with the formula, and so that becomes this. H2 plus O2 turns into H2O. Now this is not quite correct. If you look at the number of pieces there, we've got 2 hydrogens in the reactants, 2 hydrogens in the products. That all seems fine. 2 oxygens going into the equation in the reactants, but we've only got 1 at the back with the products. So there's something else going on here, because we can't have an oxygen just randomly disappear. Now what actually is the case is that equation wasn't complete. It wasn't written out completely correctly. We can't have atoms disappear, they don't get destroyed, they don't appear out of nowhere. So what we actually have to have some information in the equation that tells us how many of those pieces went in and out. This is what we call a balanced equation. So there must be 2 hydrogens in the reaction. If there's 2 hydrogens in the reactants, there must be 2 hydrogens in the products. Now we call this the law of conservation of mass. We'll come back to that a bit later, that law, but that's the idea. You've got to have the same stuff going into the equation as whatever comes out. Specifically, this is called the total mass of the reactants equals the total mass of the products. So we do this thing which we call balancing an equation to make sure that the same number of pieces go in as come out. And we do that by putting numbers in front of the formula. And we saw that earlier when we looked at the formula. The big number at the front means I've got more of those pieces. We saw 3 H2O, which meant we had 3 water molecules set up there. Let's start with this one. Let's look at this example. Hydrogen plus oxygen turns into water. H2 plus O2 turns into H2O. As we saw, this is not balanced. There's 2 hydrogens in the reactants, 2 hydrogens in the products. That's good. There's 2 oxygens in the reactants, but only 1 in the products. This is not good. So we need to get it to add up. So what actually is happening here, and what would actually be happening in the real world, is this. So we get 2 hydrogen atoms, or 2 hydrogen molecules, 2 hydrogen molecules adding to 1 oxygen molecule, and that produces 2 water molecules. So 2H2 plus O2 turns into 2H2O. Now let's just add up each of the pieces. There are 2 times 2, 4 hydrogens on the left, on the reactants. 2 times 2, 4 hydrogens on the right. That's great. 2 oxygens on the left, and now we've got 2 times 1 oxygens on the right. Perfect. So 4 hydrogens, 2 oxygens on each side. That equation is now balanced. That adds up. It's all good. Everybody's happy. So now I want you to go and have a look at these equations. Go try and balance these equations. Pause the video now. Go have a look, and we will come back in a moment, and I'll work you through the solutions. Okay, so hopefully you've had a go at that. Hopefully you found that not too bad. If you did find that really tricky, don't worry about that. This is something that we definitely will just keep working on. So let's start having a look at this first one. Sodium plus chlorine, so Na plus Cl2, turns into NaCl, so sodium chloride there. So sodium plus chlorine turns into sodium chloride. Let's work our way across. There is 1 sodium. So we have 1 sodium here, and we have 1 sodium here. So that's good. We've got 2 chlorines here, but only 1 over here. So 2 chlorines in the reactants. Now that's not obviously going to add up. So we can't take any away from the reactant side. We need to add more or multiply more into the products. So if we had 2 in the reactants, we're going to need 2 lots of our products there. 2 times NaCl. So now my 2 chlorines in my reactants, 2 chlorines in the products, that adds up. But now I don't have enough sodiums in my reactants. I only have 1 over there, 2 in my products, so I actually need 2 of those. So now we can see 2 sodiums turns into 2 sodiums, 2 chlorines into 2 chlorines. Everything looks good. All right, let's have a look at the next one. Iron plus aluminium oxide turns into iron oxide and aluminium. 1 iron turns into 2 irons. Well, that doesn't work. 2 aluminiums turns into 1 aluminium. Well, that doesn't work either. 3 oxygens. Well, that bit's okay. So what we need to do is work out what are the pieces that are missing here. So let's tackle the aluminiums first, just going alphabetical. So I've got 2 on my reactant side. I need to get 2 onto my products. Now that bit balances out. The next bit that's wrong now, so oxygens were still good. Iron, need to fix that up. 2 ions on my products, which means I need 2 on my reactants. So now 2 irons, 2 irons, 2 aluminiums, 2 aluminiums, 3 oxygens, 3 oxygens. Final example here, got 2 HCl, which is either hydrogen chloride or commonly known as hydrochloric acid. CaO, calcium oxide, turns into calcium chloride and water, dihydrogen monoxide. So we have a look through here. What's wrong? H and H, well, there's 1 on my reactants, 2 on my products. There's a problem straight away. So let's just fix that first. 2 hydrogens, that looks good. 1 chlorine multiplied by 2 on my reactants now. 2 chlorines on my products. Yep, that looks good. 1 calcium, good. 1 oxygen, good. All right, so now they all add up. Now each of these examples have just had 2 as the only number that we've had to add. That's not always the case. Sometimes you will need to add different numbers. It's just the examples that we've chosen here. Last thing on this slide before we move on, if we look at the first example there, I've got 2 Na and then 1 Cl2. You don't actually need to include that 1. That 1 could stay off, leave it blank, because then that just means there is only 1 of those, like you can see in the other examples. So I've written 2, 1, and 2 for the first one, but the other examples I've just gone 2 or left it blank. So either is okay, both are acceptable, but you do not need to write 1 if it's only 1. Okay, a bit more practice now. So what we want you to have a look at is trying to take the following descriptions, write a word equation, turn it into a chemical equation, and then have a go at balancing it. So taking it through that full process that we've just looked at. So the 3 reactions for you to have a look at. Hydrogen peroxide breaks up into water and oxygen. So hydrogen peroxide turns into water and oxygen. Methane burns in oxygen. So methane plus oxygen turns into carbon dioxide and water. And hydrochloric acid is added to magnesium. Hydrochloric acid plus magnesium turns into magnesium chloride and hydrogen. So if you need to look up any of those particular specific formulas, please go do that. I will post another video later with the solutions to these. All right, everybody, thank you.